Welcome, learners. My name is Mr. Paul Chilola once again. I represent Black Slides Online Secondary School, and I'm a science teacher there. Welcome to this lesson. This is Form 3 Physics, MSc if Form 3 Physics. Let me welcome you to MSc level of learning. MSc level consists of two classes, namely Form 3 and Form 4. And it's a 2 years program. So in the Form 4, you are going to write what is called the MSCE examinations. In order to do well in the exam, you must show seriousness from the word go, right from the first day of learning in Form 3 to the very end. Show seriousness, commitment. By this, I mean attending all the lessons, no skipping lessons, reading your notes thoroughly with understanding, practicing questions, exam-style questions, consulting your teacher where you are not sure in order to get clarification on the topics, the areas that you are not sure about. Welcome, learners. So my name is Mr. Paul Chilola. Let's be together. Welcome to our first lesson. This is lesson number 1 of your MSCE Form 3 Physics. So this is lesson number 1 on a topic called measurements. Welcome once again. So pay specific attention to the areas that I point out to be examinable, highly examinable. It's my intention to have all my candidates, my students, those that I teach online, to pass their exams, MSCE exams, with distinctions, no less than distinctions. I don't condone results that are less than distinctions. So welcome, learners. My name is Mr. Paul Chilola once again. So in this topic, just at a glance, we'll discuss, or you will learn, fundamental quantities, derived quantities, standard notations, prefixes, and SI units. But for today, in this lesson, we are going to dwell on the fundamental quantities and the derived quantities. Welcome once again. So without wasting your precious time, let's get down to the lesson of the day. This is lesson number 1 of your MSCE Form 3 Physics. We are dwelling on a topic called measurements. And in this lesson, we are going to look at fundamental quantities and derived quantities only. If we start, then in lesson number 2, we are going to look at the other aspects of measurements, such as such as standard notations, prefixes, and SI units. Welcome, learners. So in this lesson, and rather in this topic, we're going to achieve the following objectives. So by the end of this lesson, you should be able to distinguish between fundamental quantities and derived quantities with examples and their SI units. I trust God that we are going to achieve this objective in this lesson. Welcome, learners. So distinguish between fundamental quantities and the derived quantities with examples and SI units, their SI units. You should also be able to write numbers in standard or scientific notation correctly. Write numbers in standard or scientific notation in a correct way. Welcome, learners. You should be able to use common SI prefixes to express large or small measurements. So in this lesson, we are going to dwell on the first objective, which is to distinguish between fundamental quantities and derived quantities, giving examples of each and their SI units. Welcome, learners. So what are fundamental quantities? When we say quantity is fundamental, or basic, what do we mean? What do you think fundamental quantities are? Right, try to think about some examples of fundamental quantities and define fundamental quantities. What are fundamental quantities? Right? For the sake of this lesson, this topic of measurements, we are going to define fundamental quantities as the physical quantities that are independent and not defined using other quantities. That's the meaning of fundamental quantities. So the fundamental quantities are quantities that are independent and not defined using other quantities. They are also called basic quantities. So when we use the concept or the term basic quantities, you should remember that we are talking about fundamental quantities. So it's either fundamental quantities or basic quantities. We define them as quantities that are independent and not defined using other quantities. So these cannot be found by combining other quantities, either by multiplication or division. They are independent. Welcome, learners. So if you are asked to define the term fundamental quantities or basic quantities, they are quantities that are independent and not defined using other quantities. In order to determine them, you don't have to combine one or two quantities either by multiplication or division. They are independent. Welcome, learners. Some examples, examples of fundamental quantities. It will please you to know that there are only 7 fundamental quantities in physics. There aren't many. For that reason, it's so easy for you to commit this to memory, to know all these by heart. Welcome, learners. So each physical quantity has a unit which is called SI unit, and each SI unit has a symbol. So your syllabus requires that you must know all of these off by heart and their SI units, as well as the symbols of the SI units. Welcome, learners. So we have length, mass, time, temperature, especially thermodynamic temperature, electric current, luminous intensity, and amount of substance. All these are basic quantities, also called fundamental quantities. Why? Because they can be expressed independent of other quantities. Welcome, learners. So the basic quantity length has the SI unit called meter. Meter. The symbol for a meter is small m. Take note. The danger of using capital M is that capital M is already being used in chemistry to mean molality or concentration of a solution, morality. So we shall strictly adhere to using small letter for meter. Mass is measured in kilograms. Symbol for kilogram is just kg, kilogram, kg, taken from kg, kilogram. You have the symbol for SI unit of mass is the kilogram. That of time is the second small s. This problem with using capital S is that capital S is already being used in physics to represent displacement or distance. Displacement or distance. The length of path covered by a moving body is called displacement. So the symbol for displacement is capital S. So strictly here, we should use small s for second. Thermodynamic temperature. Remember, temperature is how cold or hot the object is. So the SI unit of temperature is the Kelvin. Take note that the Kelvin is written as a capital letter. Why? Because the unit, the Kelvin, which is the unit of thermodynamic temperature, is taken from a name of person whose name is Lord Kelvin. So Lord Kelvin came up with the unit or the concept of thermodynamic temperature. So the SI unit of temperature, thermodynamic temperature, is named after Lord Kelvin. So we use capital symbol. In fact, it would please you to know that units that are named after people are given in capital letters. The symbols are given capital letters. Electric current, which is just the flow of charge in a circuit, is measured in a unit called ampere. Some love to pronounce this as ampere. It's a French word. It's pronounced as ampere. The symbol for an ampere is capital A. It's named after a scientist called André Ampère. André Ampère is a French guy. So from his name, we have the unit ampere written capital A. Luminous intensity, which is the amount of brightness of light, is measured in a unit called candela. Candela. I'm sure you know what we call candle. Candle gets its name from the unit here, candela. Candle, candela. Producing light when it's burning, candela. The brightness from the bulb and whatever source of light is measured in units called candela, CD in short. Then the amount of substance, take note, this is not mass. It's simply the number of fundamental entities such as number of particles such as atoms, molecules, ions, and the radicals, and any other units of substances measured in moles. This is common in chemistry, but sometimes if you take further physics, you also talk about the mole at a certain point. Welcome learners. So the mole in short is just MOL. Take note that it's small letters. Right, so there are 7 basic quantities. Length, which is distance between 2 points. Mass, which is a quantity of matter. Time, which is the interval between events. Thermodynamic temperature, which is how cold or hot a body is. Electric current, which is the flow of charge in a circuit. Luminous intensity, which is the amount of brightness of light, and then amount of substance, which is the number of elementary entities such as atoms, molecules, ions, radicals, etc. Welcome learners. So once again, UX syllabus requires that you should be able to say the SI unit and its symbols. So for length, it's the meter, the unit is the meter, and is given the symbol M, small m. Mass is measured in kilograms. The symbol for kilogram is kg. Time is measured in seconds, and the symbol for second is S. While thermodynamic temperature is measured in kelvins, the symbol for Kelvin is K. Electric current, which is the ampere, symbol is capital A. And luminous intensity, which is the brightness of light, is measured in candela, CD. Amount of substance, which is the mole, the unit is called the mole. You'd be wondering why we use SI units in physics. We use SI units in order to avoid confusion as you cross borders worldwide, as you move from one country to another. These units are used universally. So in order to avoid confusion, we all worldwide use what are called SI units. Welcome, learners. Right? So they'll ask you, why are SI units used? It's in order to avoid confusion as you move from country to country. Show it together on this. These are all fundamental quantities, which are also called basic quantities. If you have questions, don't hesitate to text me to the number that I shared earlier on. Welcome once again. So, having looked at fundamental quantities or basic quantities, now let's look at derived quantities. What do you think derived quantities are? For the sake of this topic, we shall define derived quantities in the following manner. So these are quantities which are built from two or more fundamental quantities, and they're expressed using fundamental quantities either by multiplication or division. Derived quantities are the quantities which are built from two or more fundamental quantities. So the fundamental quantities are combined to obtain derived quantities. Combine them by either division or subtraction. Division and multiplication, but not addition and subtraction. Take note. You can use a formula to calculate derived quantities. Anything that you calculate using a formula is a derived quantity. For example, you say distance is equal to, speed is equal to distance divided by time, because you are combining distance and time. Distance and time are both fundamental quantities. So by dividing distance by time, you are finding a derived quantity called speed. Welcome, learners. So that's the definition of derived quantities. So you combine fundamental quantities to obtain derived quantities. They're expressed using fundamental units. Some examples of fundamental quantities, rather derived quantities, include moment. Moment of a force is the turning effect of a force. It's defined as the product of force and the perpendicular distance. For example, when you are opening and closing the doors and windows, there's a turning effect there about points called the pivots. Or if you have been on a seesaw, the seesaw turns about a fixed point. So the product of the force applied at some point and the distance from the turning point is called moment. You cover moment in Form 4. The SI unit of moment is a Newton meter, written in short as NM. But using basic units, moment of a force is in kilograms meter squared per second squared. So it's a practice that physics students must do to know derived units of derived quantities in terms of base units. So Newton meter is a kilogram meter square per second square. Work or energy is measured in units called joules. Symbol is a capital J. In the base unit form is kilogram meter square per second square. Take note that these are the same. Power, which is the rate of doing work or energy transferred per unit time, is measured in watts. Capital letter of a watt is, the symbol for a watt is capital W, named after James Watt. The symbol for the SI units, the base unit of power is kilogram meter square per second cubed. Take note that power is only different from energy and moment by the power here. So we have square here, kilogram meter square per second square for energy on work, and as well as for moment. So take good note. There's power of 3 there. Pressure, which is force per unit area, is measured in a unit called Pascal. PA in short is the kilogram. The base unit of pressure is kg per meter second square. Charge, which is also derived, is measured in a coulomb, symbol C, and the base units are the ampere second, just an ampere multiplied by a second. Welcome, learners. So these are the examples of derived quantities which are obtained by combining two or more fundamental quantities. Let me urge you to know these examples and also read about other examples from physics books and another source. Just check. You can also check on the internet some more examples of derived quantities. Trust me, there are just many of them. Area is another one, volume, and so on. Acceleration, speed, all those are examples. Momentum. Welcome, learners. Once again, if you have questions, don't hesitate to reach out. I'll be glad to attend to you. Welcome, learners. This is Black Slides Online Secondary School. Inform your friends wherever they are that it's possible to learn during this holiday time at a very competitively low fees. At the end of this lesson, there are contacts that I've put for you to get in touch with me in case you have questions. Welcome, learners. Alright, so before I go, I'd like you to do these questions for me. So define the term fundamental quantity. Derived quantity. State two differences between fundamental and derived quantities. So look for differences from the lesson between fundamental and derived quantities. Why do you think SI units are used in physics? Why not just use the local names of units like in Kichewa or Swahili or other languages? Welcome, learners. So give two reasons. I've given you one of the reasons in the lesson. Look for the other reason why SI units are used in physics. And also look for differences between fundamental and derived quantities. So what you do is you write the answers, you copy the question, and below it write down the answer, and take a good picture of your answers and send it to me on WhatsApp. I should be able to go through your answers and send back the grade to you. Welcome, learners. My name is Mr. Pochilola, your teacher. Don't mind the numbering here. This can be number 3, 4, because the questions are coming from the previous slide. So write true or false. SI unit of mass is gram. Just write true here or false, depending on what you think is correct. Derived quantities are made from basic quantities. Kelvin is the SI unit of temperature. Kelvin. Take note, the spelling here is not right. It's not Kelvin, this one is Kelvin. So tell me if this is true or not. The Q is the unit of pressure. Set whether it's true or not. Welcome, learners. Choose the correct answer, which is the fundamental quantity, area, time, volume, speed. So among these, pick up that which you think is fundamental. SI unit of work is, so you pick one here. We have the Newton, the watt, the joule, and Pascal. Just tell me which one is the SI unit of work. Which set has only derived quantities? Mass, length, time, temperature, current, mass, area, speed, energy, mole, candela, and the kilogram. So just circle the one that you think. By the way, you need to copy everything and then select the correct answer. Welcome, learners. My name is Mr. Pochilola, your teacher. Once again, take a picture of the answers and send them to me on WhatsApp. So in case of questions, don't hesitate. Just send your questions, your comments to the number shared here. Also, you can send your questions, queries, comments to Black Slides Online or to blackslidestutors@gmail.com. Welcome, learners. So we meet again in the next lesson. My name is Mr. Paul Chilora. Invite your friends to enroll with us during this holiday so that they too can learn.